parallel lines have to be on the same plane. They have to be like flat on the surface, but they're going in the same direction and they never touch. You'll have little arrows or triangles, extra little triangles on the ends, showing you they're parallel. But then you're going to have other lines that cross over. So the transversal is just any extra line, you can have more than one, that will cross over the parallels, and when they do, they make extra angles. So like there's a group of angles here, there's a group of angles right there. And that's what we're studying in this section. All right, first type, corresponding angles occupy similar positions. Now, corresponding is a regular English word. That means there's a couple of different ways. If you correspond with somebody, usually that means you're talking back and forth, email or writing letters, things like that. Corresponding, talking to them. But corresponding also could be something about a certain position, as in I used to teach at Crystal Springs, and I taught geometry there, and now I'm up at Terry and I'm teaching geometry here. So I'm in the same position. I didn't go from janitor to teacher. I am a teacher here and I'm a teacher here. I've just moved up into a new position. That's what corresponding is for your angles. They're going to be in the same spot, just in a new group. So here, when I look at angle 6, out of its group, right around here, let me get a little highlighter here, around this group, angle 6 is on the top right of its group. So when I come up here to this other group, what's on the top right? Angle 2. So 2 and 6 would be called corresponding angles to each other. And when the lines are parallel, okay, this is the rule about it, corresponding angles are congruent when the lines are parallel. So if I had 80 degrees here for angle 2, angle 6 would match at 80 degrees because they are corresponding in that same position. Okay, there are lots of correspondings on here, and they're just in the same spot. Whatever top left, 1 and 5, they're going to be matching too. Bottom left, those are bottom left. Everything's going to end up matching. Okay, but it's really just the one at a time that you're concerned with. So like, tell me what's corresponding with angle 2. These are turned a little different, but look at the parallels. It's like you're jumping from parallel to parallel and trying to see from this group, jump into this group. What's in the same position as 2? That would be 4. All right. What's in the same position as, well, they all jumped up there, didn't they? All right, you see all the other ones. 5 goes with 7. 3 goes with 1. Clean it up. 6 and 8. Top right, bottom right, bottom right. Everything there, and those would match with their corresponding angle. But just remember that, that's the whole definition, and that's the main one we use anyway. All right. Now, if they're not parallel, they're not going to match, but they could still be called corresponding. So if I'm looking here and comparing it here, that's not parallel with any of those lines. That's not parallel there. So I could say that 5 and 3 are in the same position. They're corresponding, but that is not going to be matching angles because they got to be parallel. Okay, 5 and 3. They're in the same spot, so they're still called corresponding, but mainly our rule is about the parallels. So I just made them parallel, so now we'll have some matches. So, where is parallel here? It's going to jump from parallel to parallel, so that means our groups are going to jump up and down comparing. This can be parallel, this is parallel to this one. So those can match, or these can be parallel to these. You can't go this way. These are still not parallel to each other, right? These lines going up. So it's got to be parallel jumping to parallel. So let's think about something. What would match angle, what would be corresponding and the same size as angle 3, angle 9. That's up here in the same position. And it's going to match because they're parallel. Alright, what's going to be a match for angle 7? Angle 7 is going to be corresponding and matching with angle 5. Good. Alright, a couple more. What about angle 1? Angle 1 is going to match 15. See, they're just doing the up and down jump because your parallels are up and down to each other. Parallel jumping to parallel, like jumping from this log over to this log. That's the only way you can have matches from group to group. Alright, so little basic, when they start doing like this, you're going to be able to get one angle and find everyone else in the group. Starting back, okay, starting with your verticals, complementary, supplementaries, you can still do those because there's a whole bunch in this group you can start with right off the bat. Vertical, supplementary, minus 180, remember those? And then the vertical, okay? And then once you've got the whole group, everything on there will jump and match the parallel that it's going to. So, 113, 113. Same position, corresponding. Okay, that's the way it works. Same thing here. Vertical, supplementary, supplementary. Everything there slides down, matches, jumps down to match there. So they're not too bad once you think about it. Now that's the main type, corresponding. Remember that word. Okay, so now we're going to start mixing it up and seeing if we can find the missing angle. Now, just like everything else, sometimes they'll give you things in the drawing, sometimes they want you to put things in the drawing. So here, they're wanting you to put in angle A is 60 degrees, and angle J down here is 70 degrees. Well, let's start back with our basics. We got verticals, complementaries, supplementaries. Do we have any verticals? Yes. 60. Do we have any complementaries, right angle boxes? No. Alright, so that leaves a supplementary, straight line, 180, so that's going to make 120. And then it has a vertical opposite to it, 120. So what we just did was to find that group right there. Now, you want to do the 70, 70 here, 110, 110. Same method, supplementaries. Alright, so now we got to figure out where E, F, G, H, M, N, P, Q, P, O come from. And you got to think, what else do I see on this drawing? These little arrows. And the arrows are saying they're parallel. So if you can highlight those parallels, it will help you to see that a little better. Okay? You have a group of angles right here that we've already found. And so what parallels will do, the corresponding angles, the ones in the same position, will match from one parallel to the other. That means that group will slide over and match everything right there. 60, 60, 120, 120. Everything in the exact same position. Top left, they match. So what's going to happen down here? The same thing. They jump from parallel to the other parallel. Everything matching. 110, 70, 110, 70. So that's the main idea behind all these problems that we're going to do with parallels, is you got to make them jump like that. Now, they can get a little more complicated, of course, like this one. And I used to put this one on the big test. I don't know. We'll see how y'all do from here on out. We're still going to start with our groups that we have an angle in. Okay, you got a group down here, 70, 70, supplementary, just like we did a minute ago, 110, 110. We got that group, 50, 50, supplementary, 130, 130. So now we got our two groups. But stop and think for a minute. How many angles are in this group right here? 1, 2, 3, 4. How many angles are in this group? 1, 2, 3, 4. How many do you see up here? Oh, ran off the page. 6. Now, there's 4 here and 4 here. That makes 8, but there's only 6 up top. Now, we're going to focus on that jump again. The parallels are still going to jump. This is 130. But it's going to be a little trickier this time. So let me clean this up. All right, see the parallels? Okay, so this group will jump up to the other parallel, not sideways, right? That's not parallel to parallel. It's got to jump parallel up to parallel. Okay, it can be if the things were turned different, but it's got to go from parallel to parallel. So that's an up and down jump, not side to side. These will slide up and match. But let's think about it for a minute. The 70 is on the bottom left. Where is it going to go when it jumps up there? Right there to E. What's going to be vertical? B. Now the 110 was right here, and it's top left, but look here. It didn't have that black line, did it? That black line goes in this other corner. We had the blue line. So 110 is going to be all of that, but we're not going to put that on there right now because it might get a little confusing. We're just going to do the smaller of the two angles, just the 70s. Because guess what? We got another group right down here. This group can slide up. What's the smaller angles that we want to make slide? How about those 50s? Bottom right, 50, bottom right, 50. Okay? Now the last thing, we don't have A and we don't have D. But a couple different ways you can get it. You could go back and think about what we were saying earlier with the 110. Remember that? These two will make 110, and you can figure that out. Or you can keep it simple and just stay up here at this top group. What's supposed to happen when it's sitting on top of the straight line? 180. What's 180 minus 50 minus 70? 60. And then the vertical is going to match 60. And then you could check it. If you're not sure, check it and see. Remember how we talked about 110? Top left, what do these two make? 110. Look at the 130, doing the same thing, because we didn't move the 130. When you look up here at the top, clean it up. 130 here, what's this right here? 130. 16, 70, 130. Okay? And then there's one other way. Wonder if anybody saw it. What is this shape right here? A triangle. What do triangles add up to be? If you didn't know, they add up to be 180. So anytime you got a triangle, the angles have to add up to 180. You could do that too. Okay? Pretty cool? Yeah. All right. Okay. So, other types of angles. The corresponding was the main one, but we have other types. Alternate interior. Now what's interior mean? It means on the inside. So I've highlighted the inside angles that are inside of the parallels, not on the outside part of the parallels. Inside part. So we're going to forget about those outside ones. Alternate means to switch back and forth. So it's not going to be a left and a right. That's supplementary, right? Those are supplementary. We're doing one from one group and one from another. We're going to do a left and a right like that. Alternate interior. One's on the left, one's on the right. They kind of flip across that line to the other side. All right? 3 and 6 are alternate interior. 4 and 5 are alternate interior. And they're going to match every time. Now, why would they match? That kind of looks like a crazy spot. Think about your numbers you'd normally have. Let's say if we had 80 here, 3 would be 80, right? Vertical. That 80 would correspond and jump down here to 6. would be 80, and see 3 and 6 match. And then the supplementary would be here, 4 would be 100, and the corresponding would match. So 4 matches 5, 3 matches 6. Alternate interior. Now let's see if you can pick out what's alternate interior here. Think about it a minute. 2 with 6, 1 with 3. Parallels are turned different, but it's still in between the parallels. Interior, right? Inside, and then one's on the left, one's on the right, or one's on the top, one's on the bottom. Alright, then we have alternate exterior. So guess where they're going to be? That's right, on the outside. So don't worry about the inside ones now, and they're going to do the same thing that the interior did, be on alternate sides. 2 and 7, 1 and 8. Alternate interior to each other, and they're going to match. They're also going to match. What are alternate interior here? Here's the interior. We don't want them, or sorry, alternate exterior. We don't want the interior. We want the exterior. So 5 is exterior, alternate exterior to 1 and 6. What is that? 4 and 8 are alternate exterior as well. Okay? And then we have consecutive, which means one right after the other, or better definition, same side interior. Same side interior. Guess where they are? They're on the inside, but they're on the same side of your parallels. Now, these are the special ones. All the other ones have matched. If you hadn't noticed that, they've all been matching with the corresponding matches. The alternate interior, alternate exterior, they all match. These don't match. These are going to make 180. They're going to be supplementary. You don't believe me? Look here. If this was 80, 3 would be 80 because of vertical, right? Then that corresponding jumps down. This is 80. And then the supplementary right here next to it, 100. 4 is vertical, will be 100. And then the alternate interior, 100. So when we're talking about the same side interior, look at 4 and 6. They're on the same side and they're on the interior. They're going to add up to be 180. Okay? So that's just the rule about those types. Corresponding is the main type we use. All right. Corresponding is the main type, but this is a special, they're called either consecutive or same side. You can call them either one you want. Alright, so consecutive here, consecutive exterior works the same way. I just didn't put a big definition. Consecutive exterior, not the interiors. Okay, that's the interior. So consecutive exterior, what do you think? 5 and 8 and 4 and 1. Okay, and they're not equal, they're supplementary. 180. Alright, come back. Now we got algebra to mix in with it. No big deal because we did a little algebra back with segment addition. Remember those? Alright, so the first thing you need to say is what kind of relationship is it? Look at the position of these two angles. Are they both interior? Are they both exterior? Nope. This one's interior. This one's exterior. So it can't be alternate interior. It can't be alternate exterior. If you're going to say interior, exterior, it has to be both of them. So what was left? Corresponding. Okay? They're in the same position, right? Bottom right, bottom right. Does that mean they're congruent, equal, or does that mean they're supplementary, 180? It means they're equal. Okay? Congruent. So what do? We put them equal to each other, and we work them out. One angle equal to the other angle. Work out the math, and you got your answer. What type would this be? Exterior, right? Something exterior, alternate exterior. Is that congruent, equal, or supplementary 180? That's an equal one. So put them equal to each other. Work it out. Alright. Next. Look at there. They're interior. Are they alternate interior? Nope, they're consecutive or same side interior. You can call them either one. What does that mean? That's a special one. That's the one that's supplementary. They add up to be 180. So guess what we're going to do? We're going to make them add together. The bottom one plus the top one equal 180 and work out the math. There you go. Alright, little quick one for the ACT. Normally when you're doing geometry you can't make your own lines, but this is called like an auxiliary line. They were trying to find this angle, but there weren't any angles in this vertex working with it. So you can do what's called an auxiliary line, extend that line on out, and now they said A is parallel to B, that was given up there. So if those are parallel, tell me what's happening with this 60, and we're parallels now, and right up here. What would 60 do with that angle right there? That would be alternate interior, so it would be 60. And then what did we say about triangles? See that triangle right there now? 180. I got 100 right there. 100 minus 100, subtract 180 is 80. And then right here next for our question, supplementary, so that would be 100. And there's a rule about these exterior angles with triangle we'll do later, but you could have worked that one. That was on the ACT one time before. Never know, they might throw it in again.